So now that we have loaded the normal of the section and the base vertex for that section, right, on the track, let's just go ahead and try to implement, I think in ship.h and ship.c, we need to implement those two forces, right? So ship update, right here, frame per frame, we have to compute how much we're going to attract and how much we're going to repel from the track, right? How much we're going to push and pull that ship from the track base. Which, let me see if I can find here. So remember how our force, all those forces that we have to add together, the acceleration, the thrust, and etc., we start with 0, right? So the force is the sum of all the forces, only thrust for now. So now we are not going to have only thrust. The force is the sum of all the forces. So force starts with 0, 0, 0. And then we apply the thrust, but a little bit before the thrust, let me just say that we're going to compute and add the force of attraction, right? So it's going to be our force upwards, right? Up. And I'm going to say that it is in the direction of the normal of the track, of the section. So that is one thing that we have to do, but also we're going to compute and add the force of repulsion, right? So repulsion, which is going to be, oops, I made a mistake. The attraction is down in the direction of the inverse of the normal, right, or the flipped of the normal, and this one, the repulsion, is up in the direction of the normal of the track. Does that make sense? I'm just kind of translating into words what we discussed before. So the attraction force is F down, and the repulsion force is F up, which we're going to do. So let's just think about the attraction force, right? This attraction to the track down. Well, for that, I am just going to have to compute here. Compute the dot product or the projection, right, to find the height between the ship and the track base. So we're going to have to compute this dot product, which I am going to go ahead and, for this dot product, we need two things. We need the normal vector of the section, which we already have, but also that vector between the base vertex and the ship. Remember that blue vector? So we need, let me just call this one base to ship dot vx. So we're going to declare a vector called base to ship right here. So vector base to ship. And I'm going to declare here a long dot product, right? So just dot, which is going to store, remember, dot product is a number, is a scalar. So that is why I'm declaring it as a long. So this thing right here, the base to ship Vx, is the result of the subtraction between the ship position minus the base vertex. So it's going to be the ship object position dot Vx minus the base vertex of the section. So section base vertex dot Vx. Correct? So this is going to give us that vector that goes from the base vertex until the ship object position. And I have to do the same thing with y and z. Y and z. Y and z. Y and z. Right, now that I have this base to ship, so the vector that goes from the base vertex to the ship, I can compute the dot product, which is, remember, it is x times x plus y times y plus z times z's, right? So this is the dot product. Which two vectors I am using? Well, it is the vector section normal, right? So section normal Vx times the base to ship dot Vx, and oops, there is a multiplication here, right? So I think we might need to take care of that shift by 12. And you know what? Let me just separate this multiplication. So I multiply and then dot plus equals the same thing. The section normal Vy times Vy shift by 12. Do you agree? I'm just separating these three things into three lines, but they are the dot product, right? It is multiplication plus multiplication plus multiplication between x's and x's, y's and y's, plus z times z's. And I'm taking care of that fixed point underflow by shifting by 12, and z times z. All right, so that takes care of our dot product. And just before we continue, let me just printf the dot product. Actually, let me call this the height, right? The dot product is going to give us that projected height. So the height is going to be, let me just print a long dot. I just want to see what is the value, right, that we have as we are projecting that height. Are we going to see the correct value of the distance on the screen? So let me just build ISO. Oops, problem. Section 125, section undeclared. Why? Of course, the section is the closest section of the ship, right? So it is the ship section. I think that the same thing here. Ship section, and ship section, normal. Perfect. No errors. So all I want to do is I want to see here on the messages if we are actually computing that height correctly. Fingers crossed. So look at that. Height 346. Right, so if I go up 400, 700, 100, there you go. And then if we go underneath, minus, right? So because we are underneath the track, the height is negative. And if we are kind of just on the track, is going to be 0. Let me just go up. Yeah, 0. Yeah, so if we are right on the track is 0, the height. And if we go up, then we have this really huge height value. I like that. So that's exactly what I wanted, the projected height. And it doesn't matter if I come here and if I go up, the height is still computing that projected height with the base of the track, right? That is exactly what we want. Super cool. So I think we got one thing done, which is the height from the base of the track until the ship. And now based on this height, we know how much we have to repel or attract, finding those F up, F down force magnitude, which is these things that we have to compute. Right, so in the next lecture, I'm just going to quickly use this height that we computed, right? This dot product that we computed, which is the height of the ship and the track. Let me actually come here and say that I'm just going to be very verbose. I'm going to say height. I'm just going to duplicate because that's what I want. And I'm going to say that the height is the dot product, right? So the dot product is the distance, right? The height, distance between the ship and the track base, right? The base of the track. Cool, so now that we're being very verbose, right? Telling exactly what it is and using these variable names that kind of make sense, now I can use the height to find the repel force and the attraction force that we have to apply into our ship to push or pull that ship up or down.